Hello world. I am Imagination. In this video, I am going to talk about fusion power. Fusion power is a proposed form of power generation that would generate electricity by using heat from nuclear fusion reactions. In a fusion process, two lighter atomic nuclei combine to form a heavier nucleus, while releasing energy. Devices designed to harness this energy are known as fusion reactors. Fusion processes require fuel in a confined environment with sufficient temperature, pressure, and confinement time to create a plasma in which fusion can occur. The combination of these figures that results in a power-producing system is known as the Lawson criterion. In stars, the most common fuel is hydrogen, and gravity provides extremely long confinement times that reach the conditions needed for fusion energy production. Proposed fusion reactors generally use hydrogen isotopes such as deuterium and tritium, which react more easily than hydrogen to allow them to reach the Lawson criterion requirements with less extreme conditions. Most designs aim to heat their fuel to tens of millions of degrees, which presents a major challenge in producing a successful design. As a source of power, nuclear fusion is expected to have several advantages over fission. These include reduced radioactivity in operation and little high-level nuclear waste, ample fuel supplies, and increased safety. For centuries, humans have dreamed of harnessing the power of the sun to energize our lives here on Earth. But we want to go beyond collecting solar energy, and one day generate our own from a mini-sun. If we're able to solve an extremely complex set of scientific and engineering problems, fusion energy promises a green, safe, unlimited source of energy. From just 1 kilogram of deuterium extracted from water per day could come enough electricity to power hundreds of thousands of homes. Since the 1950s, scientific and engineering research has generated enormous progress toward forcing hydrogen atoms to fuse together in a self-sustaining reaction, as well as a small but demonstrable amount of fusion energy. Skeptics and proponents alike note the two most important remaining challenges: maintaining the reactions over long periods of time and devising a material structure to harness the fusion power for electricity. Unlike other forms of electrical generation, such as solar, natural gas, and nuclear fission, fusion cannot be developed in miniature and then be simply scaled up. The experimental steps are large and take time to build. But the problem of abundant, clean energy will be a major calling for humankind for the next century and beyond. It would be foolhardy not to exploit fully this most promising energy source. Fusion power is clean. It emits no greenhouse gases and produces only helium and a neutron. It is safe. There is no possibility for a runaway reaction, like a nuclear fission meltdown. Rather, if there is any malfunction, the plasma cools, and the fusion reactions cease. All these attributes have motivated research for decades, and have become even more attractive over time. Engineers started construction of the world's largest nuclear fusion project in southern France, The Guardian reports, with operations planned to begin in late 2025. The project, called ITER, is an international collaborative effort between 35 countries with enormous ambitions. Prove the feasibility of fusion energy with a gigantic magnetic device called a tokamak, as per the project's official website. Enabling the exclusive use of clean energy will be a miracle for our planet, ITER Director General Bernard Bigot said, as quoted by The Guardian. ITER may be a massive international effort to make fusion energy a reality, but it's not the only one. A large number of fusion startups in the US and abroad are trying to turn it into a commercially viable source of energy as well. That's all for today. Thanks for watching.